Have you ever looked up at the night sky and wondered where it all ends? Like, does it end? Is there a wall, a curtain, a place where the stars just stop and nothing begins? It's a question that sounds so simple, almost childlike in nature, but the deeper you go, the more it messes with everything you thought you understood. Because here's the thing, when we talk about the edge of the universe, we're not talking about something like the edge of a table or the end of a road. We're talking about the boundary of reality itself, if there even is one. The universe, as we know it, is enormous, staggeringly, unfathomably, almost laughably huge. It's expanding in all directions, stretching space itself farther and farther apart. And yet, even with the most powerful telescopes, even with all the maps and models we've built, there's still this haunting, unanswered question that hangs over everything. What lies beyond? Now, maybe it's nothing. Literally nothing. Not empty space, not darkness, but a true, absolute absence. Something our human minds can barely begin to grasp. Or maybe, just maybe, there's more. Another realm, another dimension, another universe. You see, the idea of an edge implies that there's something on the other side. But in cosmology, it's not that simple. The edge might not be a place we can reach. It might be a limit of what we can observe, not what actually exists. And that's where things get really strange. Because every time we try to imagine what's beyond the edge, we're pushing against the limits of language, science, and even imagination itself. Is space curved back on itself like a giant loop? Is it infinite, or does it just feel infinite because we're trapped inside it? Are there other universes out there, invisible to us, with their own laws of physics and galaxies that will never touch ours? These questions don't come with easy answers, but they matter, not just because they're fascinating, but because they force us to confront how small we are and how much we still don't know. So tonight, as we drift through this cosmic thought experiment together, forget everything you think you know about edges, walls, and endings. The universe might not play by those rules. In fact, it might not have an edge at all. And yet, we're still left asking, what lies beyond? When we look up at the stars, what we're actually doing is looking back in time. Every beam of light that reaches our eyes has traveled across vast stretches of space, sometimes for billions of years, just to arrive in this one moment. And while it feels like we're surrounded by a calm, still night sky, the truth is far stranger. The universe isn't standing still, it's expanding, and it has been ever since the very beginning. The idea of an expanding universe sounds simple enough, but once you start pulling on that thread, everything we know about space, time, and even the concept of an edge starts to unravel. Let's rewind for a second, back to the Big Bang, the event that marked the beginning of our universe around 13.8 billion years ago. Despite the name, the Big Bang wasn't an explosion in space. It was an expansion of space itself. It didn't happen in one location. It happened everywhere, all at once. Space didn't expand into something. It expanded from something. Now here's where it gets really weird. When we say the universe is expanding, what we really mean is that space itself is stretching. Galaxies aren't flying away from each other through space. They're being carried apart by space. Imagine dots on the surface of a balloon. As you blow up the balloon, the dots move farther away from each other, not because they're moving, but because the surface they sit on is growing. This expansion is happening everywhere, and it's still happening right now. In fact, it's accelerating. Distant galaxies are moving away from us faster than ever before, and some are moving so fast that their light will never reach us, no matter how long we wait. They're slipping beyond our cosmic horizon into a part of the universe we will never be able to see. And this brings us to a crucial concept, the observable universe. The observable universe isn't the whole universe, it's just the part we can see. Light takes time to travel, so we can only observe objects whose light has had enough time to reach us since the Big Bang. That gives us a sphere with a radius of about 46 billion light years. That's our visible bubble, our cosmic horizon. But here's the mind-bending part. The universe itself might be much, much larger than what we can see, possibly infinite. The edge of the observable universe isn't a physical edge of space. It's simply the limit of how far light has traveled. And because the universe has been expanding all this time, there are regions so far away that their light hasn't had enough time to reach us, and might never. So, when we talk about the edge of the universe, what we're really talking about is the edge of visibility, a moving boundary defined not by space itself, but by the speed of light and the age of the cosmos. It's not a wall or a border, it's a horizon. And like the horizon on Earth, it moves with us. The more time passes, the farther we can see. But at the same time, parts of the universe are moving away from us so quickly that we'll never catch up to them. This is a hard idea to wrap your head around, because we tend to think of space in fixed terms, like a map or a room. But in reality, space is dynamic. It bends, it stretches, and it changes with time. It also means that the universe has no center. Every galaxy sees itself as the center of expansion, because space is expanding equally in all directions. There's no special point from which everything is moving away. Instead, space itself is growing, and everything is being pulled apart in the process. This leads to one of the biggest misconceptions, that the universe is expanding into something it's not. There's no outside that space is pushing into. Space is all there is, so the expansion is not like an explosion into a pre-existing void, but rather a scaling up of existence itself. And so, when we ask what lies beyond the edge of the universe, we first have to ask, what do we mean by edge? If we're talking about the observable universe, then yes, there's a limit to what we can see. But if we're talking about the universe as a whole, there may not be an edge at all. The expansion of the universe means that our cosmic horizon is always changing, always shifting. It's not a solid boundary, but a constantly evolving limit. As space stretches, as time flows forward, new regions of the universe may come into view, while others slip away forever. So what lies beyond that moving horizon? Possibly more galaxies, more stars, more structures that are just like what we see here. Or maybe something completely different. Or maybe, just maybe, we're looking at a never-ending fabric that goes on forever, with no edge to reach and no outside to escape to. The expanding universe doesn't give us many clear answers, but it does give us this: a humbling reminder that no matter how far we see, there's always more beyond, just out of reach, just beyond the edge of what we can know. When we imagine the edge of something, we usually picture a line, a cliff, a border, something clear and definite. So it's natural to wonder, if the universe has an edge, what happens if you get there? Can you step over it? Does space just stop? Does it fold into something else? But here's where things get beautifully strange. The universe might not have an edge at all, not because it's infinite, but because of the way space itself is shaped. Let's start with a familiar idea. Imagine you're standing on Earth, looking at the horizon. It seems flat, and if you keep walking in a straight line, you might think you'll eventually reach the edge of the planet. But we know better. Earth is a sphere. If you walk far enough in one direction, you'll loop back to where you started. No edge, just curved space. Now take that idea and stretch it out, way out, into 3 dimensions. This is how many physicists think our universe might be structured. It could be finite, but without boundaries. A shape that bends and loops in on itself so completely that you could, in theory, travel in one direction forever, and eventually end up right back where you began. This is the concept of a closed universe, a cosmos with a curved geometry, like a higher dimensional version of a sphere. In this model, there's no outer wall, no cliff where reality ends, just a continuous loop of space and time, with no true beginning and no hard edge. And yet, to us, standing here on Earth, space appears flat. Not because it is necessarily, but because we're only seeing a tiny fragment of the whole. Just like how, to a person walking on Earth, the surface feels flat, until they travel far enough to realize they're on a sphere. So, if the universe is curved in this way, why can't we tell? The answer is size. If the universe is curved, it's curved on such a massive scale that we can't detect it with our current instruments. The observable universe is like a tiny patch of land on a giant balloon. We can't see the curve because we're too small to notice it. But that doesn't mean it's not there. There are even theoretical models where space is not just curved, but multi-connected, where the universe might be shaped like a donut or a pretzel, looping back on itself in complex ways. In a space like that, you could shine a light in one direction, and billions of years later, see your own light coming back at you from the other side. You could literally see other versions of our own galaxy, repeated like reflections in a cosmic funhouse mirror. So why haven't we seen those repetitions? We've looked. Scientists have searched the sky for repeating patterns in the cosmic microwave background, the leftover glow from the Big Bang. If space looped back on itself in a small enough size, we might expect to see the same galaxy or structure appearing in more than one spot. So far, we haven't, but that only tells us that if space is wrapped, it's wrapped on a scale far larger than what we can observe. But maybe the universe is flat and infinite instead. That's what current observations seem to suggest. The data from satellites like WMAP and Planck show that, on large scales, the universe appears to be very nearly flat, meaning that parallel lines never meet and space doesn't curve back on itself. If this is true, then the universe might extend outward forever, with no looping, no repetition, and no edge. But even if space is infinite in size, that still doesn't mean we can reach its limits, because we're bounded by the speed of light and the age of the universe. There's only so far we can see, only so far we can travel. So whether space wraps around or goes on forever, we may never be able to tell. And then there's the idea of higher dimensions, that our universe might be like the surface of a balloon embedded in a higher dimensional space that we can't perceive. In this view, we're trapped in our three-dimensional experience, while the true shape of the universe plays out in realms we can't access. Imagine an ant walking on a garden hose. To the ant, the hose looks like a flat line, but we, from a higher perspective, see it for what it really is, a cylinder. In the same way, we might only be seeing a slice of a much richer cosmic structure. So, what lies beyond the edge of the universe? Maybe nothing, or maybe something our minds weren't built to comprehend. If the universe curves back on itself, then there is no beyond, because there is no edge. And if it's infinite, well, infinity is its own kind of mystery. You can never reach the end because there is no end. Just more space, more time, more silence stretching on forever. Either way, it challenges the way we think about reality. We're so used to boundaries and borders, to maps and markers. But space doesn't work that way. The universe isn't a container. It's a process, an unfolding, a shape without sides. And the more we learn, the more we realize the edge of the universe might be the edge of our understanding. Not a place we can visit, but a horizon we carry with us. A boundary not of matter or space, but of imagination. If the idea of a curved, endless universe isn't already enough to scramble the mind, there's a whole other layer of mystery that takes things even further. The possibility that what lies beyond the edge of our universe is another universe entirely. That's right, beyond the bounds of what we can see, beyond even the limits of our own cosmic bubble, there might exist other realms, other universes, other realities, operating under different laws of physics, with different kinds of matter, energy, maybe even versions of us. This isn't just science fiction. It's a serious line of thinking in modern cosmology. Let's talk about the multiverse. In its most basic form, the multiverse is the idea that our universe, everything we know, from galaxies to atoms to time itself, might be just one bubble in a much larger cosmic foam. And each of these bubbles could contain its own universe, completely sealed off from the others. We don't know what they'd look like, how they'd function, or even if interaction between them is possible. But the theory raises an astonishing possibility that our universe is not all that there is. Now, why would anyone think this is more than just a wild idea? Surprisingly, it comes from serious attempts to understand how the universe came into being. One explanation is rooted in a concept called cosmic inflation. After the Big Bang, the universe didn't just expand, it inflated at an incredible speed. Think of a balloon suddenly blowing up to a massive size in a fraction of a second. This theory helps explain why the universe appears so uniform in every direction. But inflation doesn't have to stop at just one place. It could, in theory, keep happening in other regions. If that's true, then our universe is just one pocket of space where inflation slowed down, allowing stars and galaxies to form, while in other pockets, the process is still going or has created other universes entirely. This is called eternal inflation, and it's one of the leading candidates for how a multiverse could form. Each bubble universe would have its own Big Bang, its own expansion, and potentially its own physical laws. Gravity might work differently. Time might not even exist in the way we understand it. Some of these universes might be empty and cold. Others could be teeming with forms of life we can't even imagine. And because each bubble is expanding on its own, there's no way for us to cross over or see into any of them. They'd be forever separate, an invisible landscape of realities, each isolated, each complete in itself. But there are other kinds of multiverse ideas too. There's the quantum multiverse, which comes out of quantum mechanics. According to the many worlds interpretation, every time a decision is made, the universe splits into different branches, one for each possible outcome. So in one universe, you decided to watch this video. In another, you didn't. In one, you moved to a new city. In another, you stayed. Every choice, every quantum event spins off into a new reality. If that's true, then our universe is surrounded not by physical edges, but by an endless stack of parallel versions of itself, all branching, all evolving, all equally real. Then there's string theory, which suggests that our universe might be a kind of three-dimensional membrane, or brain, floating in a higher dimensional space called hyperspace. In this view, other brains could be floating nearby, each one a separate universe with its own unique properties. Some scientists even suggest that the Big Bang itself could have been the result of two brains colliding, unleashing the energy that became our universe. These ideas are all incredibly speculative. We haven't seen direct evidence for any of them, but they're not just made up out of thin air. They're based on attempts to answer some of the most fundamental questions in physics. Questions like, why does the universe have the properties it does? Why is the Big Bang the way it is? Why is there something rather than nothing? Some physicists believe the multiverse provides a kind of explanation. If there are infinite universes, each with different properties, then it's not surprising that one of them would happen to support life, and we just happen to live in that one. Not because it's special, but because it's the only one we could live in. This is known as the anthropic principle. But here's the challenge. If these other universes exist, how could we ever know? They might be forever beyond our reach, unobservable, untouchable, unprovable. and yet their existence would change everything. It would mean our universe is not the totality of existence, but a small part of a much larger, almost unfathomable reality. Still, some scientists are working on ways we might someday detect them. For instance, if our universe ever bumped into another bubble, it might leave a subtle mark, like a scar in the cosmic microwave background. The afterglow of the Big Bang. We've searched for those signs. So far, nothing conclusive. But the search continues. And even if we never find physical evidence, the multiverse opens up a new way of thinking. A way of seeing ourselves not as the center of everything, but as one expression among countless others. That perspective can be humbling, but also strangely empowering, because it means the edge of our universe, the place we think of as the boundary of everything, might just be the doorway to something bigger. Not in the way we can pass through it, but in the sense that reality might be far more vast, far more layered, and far more mysterious than we ever dared to believe. We may never see those other universes, but their possibility challenges us to keep pushing the boundaries of science, imagination, and understanding. Because maybe the edge we're staring at isn't an ending. It's just the beginning of everything we've yet to discover. So far, we've explored the expanding universe, the idea of a boundless curved space, and even the possibility of multiverses lurking beyond our cosmic bubble. But now we reach a more subtle, yet equally profound frontier, ourselves. Because maybe the real edge of the universe isn't out there in deep space or behind some cosmic curtain. Maybe it's right here in our minds. We humans like to think we're good at observing the world around us. We trust our senses, our instruments, our logic. We've built telescopes that can peer 13 billion years into the past, equations that describe black holes and galaxies, and simulations that model the birth of the cosmos. But for all our brilliance, for all our tools and theories, there's something we can't escape. We are limited by what we can perceive. Let's start with the basics. Our eyes can only detect a tiny sliver of the electromagnetic spectrum. We can't see X-rays, gamma rays, or even the full range of infrared light. The visible universe, for us, is already filtered. We're not seeing everything that's there. We're seeing what we're built to see. Now think bigger. We only experience time in one direction, forward. We live moment by moment, never able to step outside the flow. But the laws of physics don't require time to move one way. In fact, many equations are time symmetric. The arrow of time may be a feature of how we observe the universe, not a fundamental rule. Space too is curved and warped by gravity in ways we can't feel directly. We rely on instruments, mathematics, telescopes, sensors to show us the fabric of reality. But we don't experience that curvature. To us, it feels flat, simple, obvious, but it isn't. The real universe is strange and counterintuitive, and we're only scratching the surface of what it's like. And here's the thing, our brains evolved to survive, not to understand the cosmos. Our ancestors needed to hunt, build, shelter, recognize danger, not contemplate the edge of space-time. So the way we process information, the way we understand distance, size, and existence is shaped by what helped us stay alive. That doesn't mean we can't explore deep truths, but it does mean we might not be wired to fully grasp them. What lies beyond the universe? We don't even really know what lies within the universe, at least not entirely. Dark matter makes up most of the mass in the universe, but we don't know what it is. Dark energy drives cosmic expansion, but we don't understand how it works. Every time we uncover one layer, another mystery opens up beneath it. It's not just that there are unknowns, it's that there might be unknowables. Realities that sit beyond our sensory limits, beyond our technological reach, maybe even beyond the limits of human thought. Think of a goldfish in a bowl, It can swim, breathe, respond to light and motion, but it has no concept of the room it's in, or the people watching it, or the planet it's living on. It's not because it's not curious, it's because it can't know. Its world is bounded by the bowl. Now ask yourself, are we in a cosmic bowl too? Is the universe we see just a fraction of the whole picture, limited not by the cosmos itself, but by the way we're built to observe it? Even our tools, our telescopes, satellites, and computers are extensions of us. They help us see further, measure better, calculate faster, but they're still bound by the same fundamental limit. We can only detect what interacts with us in some measurable way. We can't observe what doesn't emit or reflect light. We can't receive signals from regions of the universe receding faster than the speed of light. There are entire realms we can never touch, no matter how advanced we become. And that brings us to the observable universe again. When we say we're looking at galaxies 13 billion light years away, we're not seeing them as they are now. We're seeing them as they were 13 billion years ago. That means we're always looking into the past, never the present. The now of those distant galaxies is forever out of reach. Even more sobering, some galaxies have already passed beyond our horizon, not because they vanished, but because the universe's expansion has pushed them so far away that their light will never reach us again. They are lost to us, not just practically, but permanently. That's not a technology problem. That's a cosmic fact. And it's not just what's outside. We're limited in how we understand what's inside. Our minds are trapped inside a bubble of perception. We don't experience objective reality. We experience interpretations of it. Our thoughts are shaped by language, memory, emotion. Our brains are wired with biases, shortcuts, limitations. So when we ask, what lies beyond the edge of the universe? We have to acknowledge this. The edge might not be physical, it might be cognitive. Maybe we can't see what's beyond because there's nothing there. Or maybe we can't see it because we're not designed to, and yet we wonder. That's the most incredible part. Despite our limits, we reach, we build machines to stretch our vision. We create theories to stretch our understanding. We tell stories, craft models, challenge the very boundaries of what we know. Because curiosity is our edge. It's the tool we use to push past the boundaries, even when we know we might never cross them. And every question we ask, every what if, and what lies beyond, is an act of defiance against the darkness. We may never know what lies beyond the edge of the universe, but maybe the point isn't to reach the edge. Maybe the point is to keep moving toward it, no matter how far it retreats. Because in that pursuit, in the asking, the imagining, the not knowing, we touch something infinite. And maybe, just maybe, that's the closest we'll ever get. We began this journey with a simple question, a question that almost every curious mind has asked at least once. What lies beyond the edge of the universe? And now, after diving into the mysteries of cosmic expansion, curved space, multiverses, and the boundaries of our own perception, we find ourselves in a place where the answers aren't as straightforward as we hoped. Because the truth is, there might not be an edge. There might be no outer rim, no final border, no wall at the end of it all. The universe could be infinite, stretching endlessly in all directions. Or it could be finite but unbounded, looping back in on itself in a way we can't intuitively grasp. It could be just one universe among countless others, each hidden in its own bubble of space and time. Or the edge might be something we'll never see, not because it doesn't exist, but because we simply can't reach it, physically or mentally. We like to imagine frontiers, places we can conquer, lines we can cross, lands we can map. But the universe isn't a land. It isn't even a thing in the way we normally understand things. It's a dynamic, expanding, evolving fabric of reality that might not play by any of the rules we expect. And yet, the most profound realization might not be about what's out there. It might be about what's in here. The fact that we, tiny specks on a small rock orbiting an ordinary star, are capable of asking these questions at all. That we can stare into the void, measure the afterglow of the Big Bang, build machines that catch whispers from billions of light years away, and still have the humility to admit we don't know what's beyond the edge. That's extraordinary. Because the edge of the universe might not be a place, it might be a limit of understanding, and understanding can always grow. So what lies beyond? Maybe nothing, maybe everything. But in chasing that mystery, in imagining what could exist past the final horizon, we do something uniquely human. We expand the universe within ourselves. Thank you for joining us on this journey beyond the stars and into the unknown. If this video sparked your imagination, helped you see the universe in a new light, or simply made you stop and wonder, please like, comment, and subscribe to the Storyteller Panda for more explorations into the mysteries of space, time, philosophy, and existence. What do you think lies beyond the edge of the universe? Let's talk about it in the comments. I'd love to hear your theories.